determine the minimum size of aluminum feeder conductors protected by a 100 amp circuit breaker with 75 degrees Celsius rated terminals supplied from a three-phase service for a car wash, we need to refer to the National Electrical Code, specifically the ampacity tables found in Article 310. The appropriate table to use depends on the installation method and conductor type. In this case, we are using THHN aluminum conductors and 75 degrees Celsius rated terminals. The 75 degrees Celsius temperature rating is crucial because it dictates the maximum ampacity we can use for the conductors. This is important because the terminals on the equipment are only rated for 75 degrees Celsius, and the conductors cannot operate at a higher temperature than the lowest rated termination point. For a 100 amp overcurrent protection device, we need to find a conductor size that has an ampacity equal to or greater than 100 amps when rated at 75 degrees Celsius. We need to consult NEC Table 310.15. B16, which provides the allowable ampacities of insulated conductors rated up to and including 2000 volts, 60 degrees Celsius through 90 degrees Celsius, in free air based on ambient air temperature. When using this table, we look for the aluminum conductor column and the 75 degrees Celsius row. We need to find a conductor size that has an ampacity of at least 100 amps. According to NEC Table 310.15. B16, a 1/0 aluminum conductor, has an ampacity of 120 amps at 75 degrees Celsius. Since 120 amps is greater than 100 amps, a 1/0 aluminum conductor is suitable for this application. Therefore, the minimum size THHN aluminum feeder conductors protected by a 100 amp circuit breaker with 75 degrees Celsius rated terminals supplied from a three-phase service for a car wash shall be 1/0. It's important to remember that this calculation assumes standard installation conditions. Factors such as ambient temperature, number of conductors in a raceway, and voltage drop can affect the required conductor size. Adjustments may be necessary based on these factors. For example, if the ambient temperature is higher than 30 degrees Celsius, we need to apply a correction factor to the ampacity of the conductors. Similarly, if there are more than 3 current carrying conductors in a raceway, we need to apply a directing factor to the ampacity. Furthermore, voltage drop should be considered to ensure that the voltage of the car wash equipment is within acceptable limits. The NEC recommends that voltage drop should not exceed 3% for feeders and 5% for feeders and branch circuits combined. To calculate voltage drop, we need to know the length of the feeder conductors, the current flowing through them, and the impedance of the conductors. The formula for voltage drop is voltage drop equals 2 times K times I times D divided by Cm, where K is the constant for the conductor material, I is the current in amps, D is the distance in feet, and Cm is the circular mils of the conductor. By considering these factors, we can ensure that the aluminum feeder conductors are properly sized for the car wash service, providing safe and reliable operation. It's also important to consult with a qualified electrical engineer or electrician to ensure compliance with all applicable codes and regulations. They can provide expert guidance and ensure that the electrical system is designed and installed correctly. In summary, selecting the right conductor size for the car wash involves several key steps. Firstly, determine the load requirements, which in this case is 100 amps. Secondly, identify the conductor type, which is THHN aluminum. Thirdly, establish the temperature rating of the terminals, which is 75 degrees Celsius. Fourthly, consult NEC Table 310.15. B16 to find the appropriate conductor size based on ampacity and temperature rating. Fifthly, apply any necessary correction or directing factors based on ambient temperature or number of conductors in a raceway. Sixthly, calculate voltage drop to ensure it is within acceptable limits. And seventhly, consult with a qualified professional to ensure compliance and proper installation. Adhering to these steps will result in a safe and efficient electrical system for the car wash. Additionally, it's important to consider the long-term needs of the car wash. If there are plans to expand the facility or add more equipment in the future, it may be prudent to upsize the feeder conductors to accommodate the increased load. This can save time and money in the long run by avoiding the need to replace the conductors later. Furthermore, it's important to ensure that the conductors are properly protected from physical damage. This can be achieved by installing them in a conduit or other protective enclosure. The type of conduit or enclosure will depend on the location of the conductors and the potential for damage. For example, if the conductors are installed underground, they should be installed in a rigid metal conduit or a reinforced thermosetting resin conduit. If the conductors are installed above ground, they can be installed in an electrical metallic tubing or a flexible metal conduit. In addition to protecting the conductors from physical damage, it's also important to protect them from corrosion. Aluminum conductors are susceptible to corrosion in certain environments, particularly in the presence of moisture and salt. To prevent corrosion, the conductors should be properly insulated and sealed. The connection should also be made with corrosion-resistant connectors. Proper grounding is another critical aspect of electrical safety. The grounding system provides a path for fault current to flow back to the source, which helps to trip the circuit breaker or fuse and prevent electrical shock. The grounding system should be installed in accordance with NEC Article 250. The size of the grounding conductor should be based on the size of the feeder conductors. In this case, since the feeder conductors are 1/0 aluminum, the grounding conductor should be at least number 6 AWG copper or number 4 AWG aluminum. Regular maintenance is also important to ensure the continued safe and reliable operation of the electrical system. The electrical system should be inspected periodically by a qualified electrician to identify any potential problems. The inspection should include checking the condition of the conductors, connections, and equipment. Any damaged or worn components should be replaced immediately. Furthermore, the circuit breaker should be tested periodically to ensure that they are operating properly. Circuit breakers can fail over time, so it's important to test them to make sure they will trip when needed. The testing should be performed by a qualified electrician using specialized testing equipment. By following these best practices, the car wash can ensure that its electrical system is safe, reliable, and compliant with all applicable codes and regulations. This will help to protect employees, customers, and property from electrical hazards. The NEC is updated every 3 years, so it's important to stay up to date on the latest requirement. The NEC is available for purchase from the National Fire Protection Association or from other online retailers. In addition to the NEC, there may be other local codes and regulations that apply to electrical installations. It's important to check with the local building department or electrical inspector to determine the specific requirements for the car wash. Compliance with these codes and regulations is essential to ensure the safety of the electrical system. Finally, it's important to document all aspects of the electrical system, including the conductor sizes, circuit breaker ratings, and grounding system. This documentation should be kept in a safe place and should be readily available for inspection. The documentation can be helpful for troubleshooting problems and for making future modifications to the electrical system. In conclusion, selecting the appropriate size aluminum feeder conductors for a 100 amp car wash service involves careful consideration of several factors, including the conductor type, temperature rating, ampacity, correction and derating factors, voltage drop, and grounding requirements. Consulting with a qualified electrical professional is essential to ensure compliance with all applicable codes and regulations and to ensure the safety and reliability of the electrical system. Remember, 1/0 aluminum is the minimum size based on the provided information, but a comprehensive assessment of the entire electrical system is crucial for a safe and efficient installation. Furthermore, it is important to consider future expansion and load requirements. Upsizing the conductors can prevent future costly replacements. Also, proper protection from physical damage and corrosion is essential for longevity. Regular maintenance and periodic inspections are vital to ensure the continued safe and reliable operation of the electrical system. Keep up to date with the latest NEC requirements and local regulations. Document all aspects of the electrical system for easy reference and troubleshooting. Adhering to these guidelines will ensure a safe and efficient electrical system for the car wash. The information provided is for general guidance only and should not be considered a substitute for professional electrical engineering advice. Always consult with a qualified electrical engineer or electrician before making any decisions about your electrical system. They can assess your specific needs and provide recommendations tailored to your situation. This ensures safety and compliance with all applicable codes and regulations. Always prioritize safety when working with electricity. Electricity can be dangerous if not handled properly. If you are not comfortable working with electricity, hire a qualified electrician to do the work for you. They have the training and experience to perform electrical work safely and correctly. It is important to understand that working with electricity can be hazardous, and it is essential to take all necessary precautions to protect yourself and others from electrical shock. Always turn off the power before working on any electrical circuits. Use insulated tools and wear appropriate personal protective equipment such as safety glasses and gloves. If you are unsure about anything, consult with a qualified electrician. They can provide guidance and assistance to ensure that the electrical work is performed safely and correctly. Remember, safety is always the top priority when working with electricity. By following these precautions and consulting with a qualified professional, you can minimize the risk of electrical shock and ensure the safe operation of your electrical system. Understanding the fundamentals of electrical systems is crucial for ensuring safety and efficiency. From selecting the right conductor sizes to implementing proper grounding techniques, each aspect plays a vital role in the overall performance and reliability of the electrical infrastructure. By staying informed, adhering to industry standards, and seeking professional guidance when needed, you can contribute to creating a safer and more sustainable electrical environment. Therefore, always prioritize safety and compliance to ensure the well-being of yourself and others, as well as the longevity and efficiency of the electrical systems that power our world.